This is going to be a really cool project where you can see the power of Arduino. Have you ever thought about building your very own phone? One that you can make actual phone calls and send text messages with? Well then this is a project for you. We are going to build our own open source phone. Thanks to the brilliant folks at Adafruit, we will be using their Phoner 800 breakout board to create our very own open source phone. And get this, you can even tune into FM frequencies and listen to the radio with this circuit. Talk about impressing your friends and family with this project. I have saved this project for last in the course because I know a lot of my students have been interested in building this one. Let's get the show on the road. Here are the objectives for this lesson. By successfully completing this project, we will have mastered the following items. We will be taking a look at the components that would be needed to construct the phone, and we will understand how they need to be connected together and examine the pinouts in detail for the Phoner 800 breakout board. If you are ready to begin, like I am for this one, then let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, the Adafruit Phoner 800 breakout board, or the Adafruit Phoner 800 shield, a right-angle mini GSM quad-band antenna, a lithium-ion polymer battery, specifically rated at 3.7 volts and 1200 milliamp hours, a cell phone TRRS headset where the headphones and microphone are combined in one headset, a 2G SIM card, and connecting wires. If you want to take your phone to the next level, here are some additional parts you can use to add some bling to your phone. A mini metal speaker with wires, 8 ohms at 0.5 watts, a vibrating mini motor disc, and a wired miniature electret microphone. Let's take a look at the features for our phone. Our phone will be able to connect to any global GSM network with a 2G SIM card. It can make and receive calls and also send and receive text messages or SMS messages. It can send and receive GPRS data via TCP/IP or HTTP, etc. And it can scan and receive FM broadcasts. There's an AT command interface with autoboard detection and a PWM buzzer vibrational motor control. A handy feature is that there's also an onboard battery charging circuit to recharge your LiPo battery. Let's delve into the Phoner mini GSM pinouts and connections. There's a GST 2-pin connector that's used to connect the battery input, a micro USB connector which is used as the charging port for your battery, a headset jack that is used to connect the TRRS 3.5mm headset, an antenna port that's used to connect the quad-band GSM GPRS antenna, and to the back of the breakout board is a SIM connector where you would insert your 2G SIM card. With regards to the pinouts and the connections that need to be made to the Arduino, VIO is the power connector, and that's connected to 5 volts on the Arduino. The ground pin on the board is connected to the ground pin on the Arduino. The key pin on the board is connected to ground on the Arduino. The reset pin is connected to pin 4 on the Arduino. The receive pin for UART is connected to pin 2 on the Arduino, and the transmit pin for UART is connected to pin 3 on the Arduino. Those are the connections that we'll be making for our circuit. I'd like to address obtaining a SIM card for our project. The particular version of the breakout board we're using is a 2G breakout board. That means it only supports 2G networks. If you're in the US, you'll need to get a 2G mini SIM card. Remember, it's the mini SIM and not the micro SIM card. From a carrier perspective, It's important to note that AT&T is shutting down their 2G SIM network support. From the last account, at the end of 2016 will be the end of 2G support. T-Mobile, however, still sells and supports 2G technology. I would recommend for the project getting a Ting SIM card, and I will place a link to this in the resources section for our project. If you're outside of the US, what you'll need to do is you'll need to look for a 2G SIM card with a local carrier for a GSM network. I also wanted to point out that at the time that this project was filmed, the 3G model of the phone is available from Adafruit. However, the software is still very new and not yet mature. At a later time, I will probably refilm this video incorporating the newer 3G model. It's just, at the time I made this video, it wasn't ready for prime time. There's still some bugs in the software to work out. The 2G model has been around for quite some time and is very stable. That's why I decided to use it for our project. Let's talk about the assembly for our circuit. There is a header strip that will need to be attached or soldered onto the breakout board. It's a fairly straightforward task, but if you're new to soldering, I'll include a couple of links in the resources of the project. These are very good tutorials on the soldering process. Next, we'll have to attach the antenna and a battery to our circuit. And then this will be followed by insertion of the SIM card at the back of the breakout board. Then we'll proceed to make the appropriate Arduino connections and our assembly should be complete. Now we're going to wire up all the components to create our open source phone. So before we begin, I'll just go through the list of parts that we have here. So first we have our lithium-ion polymer battery. It's rated at 3.7 volts and 1200 milliamp hours. Next we have our antenna, and this is the right angle mini GSM quad band antenna. Next we have our SIM card. So this is the 2G SIM card, which we will attach to the back of our breakout board. This is the breakout board, the Fona 800 from Adafruit. So here, this is where the antenna actually has to be connected. And we have the headphone jack. So here is the USB port where you can plug in a USB cable to charge the battery. Then at the back, here is where we would insert the SIM card. And these are the pins. As you noticed, I had to solder on a male header pin stack. Once that's soldered on, we should be good to go. We could connect this to a breadboard. The Arduino Uno, of course. And here I just have a pair of headphones. So we'll use this to actually connect to the breakout board to be able to listen in and speak when we are making and receiving phone calls. Okay, so first let's assemble the components on the breakout board itself. So I'll put in the antenna. So I'm going to screw this in. So this screws in here. Alright, so our antenna is now securely in place. Next, I will insert the SIM card at the back of the board. So if you notice on this socket here, to open it up, we just push it down. I'm going to insert the SIM card. Alright, so once it's in place, I can close this up and push the tab down and up a bit, and now it's securely in place. So there is our SIM card, it has been installed. Next, we could insert the headphone jack. So I'll just go ahead and do that. Alright, and then finally we will insert our battery. But before we power everything up, let's put the actual breakout board onto the breadboard so we can wire up our connections. Alright, so now it's firmly in place on the breadboard. And when we wire everything up, then we will connect the battery. Now that we've assembled all the components on the Fona 800 breakout board, let's connect the board to the Arduino. First, I'll connect the ground rail. So ground on the breadboard. We'll go to ground on the Arduino. Next, I'll connect the 5 volts rail. So 5 volts. The Arduino goes to the 5 volts rail. VIO from the Fona board goes to the 5 volts rail. So VIO is this first pin here. Goes to 5 volts. Next, ground goes to ground. So ground is this pin here, which is second from the left, goes to ground. Next, the key pin goes to ground. So this is a key pin here, goes to ground. The reset pin goes to pin 4 on the Arduino. This is the reset, goes to pin 4. The receive pin goes to pin 2 on the Arduino. So here's the receive pin. And finally, the transmit pin goes to pin 3 on the Arduino. So here's the transmit pin right next to the receive pin, goes to pin 3. Alright, so the last thing that we need to do is connect our battery. One thing you have to be aware of is the polarity of the battery. Right, so here the battery goes, and we push it firmly in place, and now everything is connected. Next, we will upload the code to the Arduino, and we'll test out our phone. To summarize, in this project, you learned how the Adafruit Fona 800 breakout board could be used to build an open source phone. You learned about the pinouts of the Fona 800 and the different parts and components that we need to construct our phone. We were able to wire up all our components to create our device. In the next lesson, we will test our phone and see how we can use it to make phone calls and send and receive text messages.